So at this point, we've got loads up and running on our system and even interpartition system. I want to try to demonstrate getting to some of the UV statistics through the Perfomance Co-Pilot utility. So this module is to describe the purpose of a Perfomance Co-Pilot, and we got a couple of key commands here. pmcd is the data collector that is reading this type of data. This data is basically the same data that the SAR command and top vmstat are getting to. We have to have a pmcd daemon running to be able to connect to it. Once we have a daemon running, pminfo allows me to see what metrics I can get to. There's a pminfo-t option that will print all your available metrics. CPU utilization, memory usage, disk activity, things of that sort. We also want to be able to configure archives to be able to collect PCP archives, for example, the end of the month, be able to get a plot or something like that. Again, I'm using Ganglia to be able to do actual weekly, monthly, and yearly type of PCP type data collection or SAR type of data collection. These types of archives would be more useful to drill into a particular problem, run it during a week, and then identify what kind of problems you had during the week. We also want to use the key thing in this lab and demonstration and module is the pmchart command. Now, pmchart is a complete rewrite from what it was in the SGI days and the IRIX days and ProPact 6 days. Once we PCP became completely open source, and pmchart is now a new open source version, not the SGI proprietary version. By the way, the proprietary version, the older version, is still out there. It's in a PCP-SGI RPM. We also have something called PMIE. PMIE is my performance metric inference engine. I would have just called it pmalarm. If some particular metric goes above a particular threshold, we can write something into varlog messages or run a script. If we write into varlog messages, ESP, the embedded support partner, can be configured to see that varlog message and even set up a pager. For example, PMIE may be able to catch you've got high system time, high context switching, your swap is filling up, things of that sort, and then ESP can take action on that and send you email, set up a pager, things of that sort. And there's a command, PMIE comp, that configures the threshold alarm rules. Do I want my system time alarm to go off at 40% system time or 80% system time or 10? Where do I want to set that alarm? And do I want to turn the alarm on or off? Things of that sort. What action do I want with the alarm? I got 4 actions. The default is to write into varlog messages. I also can set off a console message, run a script, or pop up a X11 graphic GUI type of message. So, when I'm looking at the system, there are 2 sides to the equation. We want both system performance data, which is what SAR, PCP, top, vmstat get to, and we want single program execution. Yesterday I was using CSA to get to my per process accounting data. But again, CSA has been retired as of Performance Suite 1.0, and now I'm moving to PBS accounting data to get my CPU user time, my wall clock time, my elapsed time, my queue wait times, things of that sort. Now, when I'm looking at a system, there are 4 modes. We've already kind of started Ganglia. If my systems were up, I'd point my browser to Ganglia and be able to look at the system for the past week, or I've got systems out there that might have a couple of months worth of data. So Ganglia gives me a historical baseline. This is something that a lot of analysts don't do. They don't go to the big picture or the historical baseline. They may look at an hour's worth of data, a few minutes worth of data. They may look at 1-second samples for 5 minutes, but there aren't a whole lot of people that go in and look at the last 3 months worth of data and say, what has my CPU time been like for the last month? What has context switching been like? When people are looking at these raw numbers with SAR, PCP, or whatever, they always ask what's a good number, what's a bad number. That's what the baseline gives you. It gives you the reference. And generally, we're first looking for those 100-year storms to find out what happened. Then we're looking for abnormal behavior. That's really what PCP and SAR are, is a behavioral analysis tool. I'm trying to look for bad behaviors, misbehaving psychotic computers. As I always describe it as you're the shrink looking at the system. You're an analyst looking for behavioral problems. So from the baseline, I can see what my typical behaviors are like for the last month. Then when I'm looking live, I've got perspective, I've got reference. So we were going to be doing live analysis today, did a little bit of it yesterday. Earlier in the week, I also used SAR and TOP when we had that 10% system time on the SMN. So SAR is a very useful tool. It gets loaded by default from the Systat package when Performance Suite is installed. And I think most of you used TOP before. We'll come back to TOP. Don't forget, right now we're in the multi-threading area, and TOP does not show threads by default. You need a capital H in TOP to be able to see threads. And then we have pmchart. And again, pmchart is a graphical GUI to be able to look at SAR type of data. And I want to build a pmchart like I did yesterday again, and actually run some I/O and things of that sort. Now, while I'm watching the system live, I might have something of interest to me. I can turn on a recorder. So PCP has in the pull-down menus the ability to record what you're seeing and actually save an archive of the event that you're watching, and then you could play it back later. Or I can configure pmlogger and save archives, for example, the last day, the last week, the last month, go into that archive and play it back. Now, in the lab tarball, there is a PCP archive for you to run pmchart on. The hard part for you is the fact that you're going to have to run pmchart within a VNC viewer or a web browser, because it's going to be X11. If you really want to go one step further, you can go up to oss.sgi.com and download pmchart for the workstation that you're working with. If you're somebody that's going to be using pmchart, I would do that. So I do have an archive out there to look at, and I do want to try to make an archive of an event that we do today. The fourth mode of analysis is where we are right now. The system is cat-erring and panicking, and post-mortem is basically saying, I can't get in the system to do anything, so I got to jump in and look at it later. And this is using crash and KDB. So even though we're not doing performance analysis, we are analyzing a behavioral problem after the system is rolled over and died on us. The hard part right now is those cat errors. I'm going to start needing to look at the blade consoles themselves, like we just saw on our example. So again, when I'm looking at the system, I want to start with the big picture, and SAR-U is the basic thing. What I'm going to do is build a PCP chart today that gives me the big picture in a GUI. Again, try to have a perspective. I need to have a reference. What's a good number? What's a bad number? I want to know what system time is like for the last month to decide whether my system time is normal or not. So when I'm looking at the system, there are three levels. There's a hierarchy as I'm going through the system to analyze things. PCP is at the top level, what I call health of the system metrics. How healthy is the system? So every time I look at the system, how busy is it? How busy is the CPU? Over on the left, I basically am going to go through these 6 resources and say, how busy is the CPU and how many things are using it? How busy is memory? How many processes? How busy is disk and how many I/O operations? Then we've got something called the file system buffer cache. Now that's kind of a Unix name for this thing. File system means metadata. For us, the file system data is in the slab. The slab is the kernel heap. So that's where your inodes and your directories and your superblocks are contained. So whenever you talk about file system, you're talking about metadata. Buffer is for the write traffic, and we call that dirty. Purpose of a buffer is to sectorize my data, to hold my data until there's enough data there to make it well-formed and friendly to the file system. And again, our file systems are block devices, so these dirty buffers are always going to be what we call sectorized or well-formed. And it's the purpose of the flush daemon to flush a lot of this stuff. Now, the flush daemon is part of the advanced sysadmin class, but there are some critical sysctl parameters on UV. The one I consider the most critical is dirty underscore ratio, dropping that down to 5 instead of 40, to not let 40% of my memory get dirty on a UV, because that's going to give you problems. I want to do that today. So the buffer is my write traffic, and anything that the program does a write that's going off to the file system, off to disk, is going to be marked as dirty. By the way, if I take a power interruption, it's dirty data that gets lost. The third piece of this is the file system buffer, or is the cache itself. Cache is for read and reuse. And the cache field in Linux has got a whole bunch of things in it that we need to talk about later. Anyway, after those, I look at interprocess communication and then networks. Interprocess communication is the IPCS command. Interprocess communication, in particular the shared memory, is out of physical memory, and I could end up with a memory leak having unattached shared memory segments. So when I'm going back to where we were, when I'm going through my health of the system metrics, I want to walk through all 6 resources as quick as I can to find out how healthy are they, how busy are they, how much are they doing, how much work are they doing. Now, when I'm at health of the system, the first set of metrics we really care about, which is what we're experiencing right now in our system, is mean time between interrupts. Once we started pushing the GRU DMA, we started getting some stability problems. ESP, the embedded support partner in the next module, is going to give us some of those mean time between interrupts statistics. So I can't really tune right now or make performance analysis until I get past the stability. After that, then I said utilization. How busy is it and how many things are trying to use it? So we can get that information from TOP and SAR and then Performance CoPilot itself. Now to me, Performance CoPilot is an oxymoron. There's nothing in it that gives me performance. Why do I say that? Because to me, performance is time to solution. Everything I'm trying to do is to get from a frequency domain into a time domain. There's nothing in PCP that gives me time to solution. And that's why I was talking about using accounting data. So I could have a system that's 100% busy and not getting any work done, or I could have a system that's 10% busy and getting a lot of work done. Just because the CPUs are busy doesn't mean they're productively doing work. And that's where hardware counters come in to be able to look for cache misses, TLB misses, front-end stalls, and various non-productive user CPU time. So somebody was talking about how their customers just throw the work at the system. But I showed you data yesterday where my 10-second process went as much as 40 seconds for the same work. That means that I could actually lose 75% of my throughput on this machine and still have 100% busy on my CPUs. So you need to be able to get into profiling to look at things in more detail. Again, I can be on a system and health of the system says it's 100% busy. This code 2 that we're running, worst case scenario for me was 3 weeks for the same calculation. It was stuck on a barrier. I can do the same thing with code 6 right now. I can make it run for weeks or I can get it done in 5 seconds. It's the same calculation, it's the same program, but I can do things good or bad. And in both cases, it's basically what I call barrier synchronization problems. They're sticking on barriers. And I can't tell you the number of times I go out to sites and see processes that are stuck on a barrier. When I run my classes with programmers and stuff, one student will be running an MPI application and the other one will step on their CPUs, and you watch the other program basically stick on a barrier and stop working, actually lock out, deadlock. Our number one problem that I see out there is barrier synchronization. This is kind of like playing phone tag between threads. When I'm multi-threading, my CPUs, each of the individual threads have to check with each other to say if they're done. Now you need a synchronization point, and that's called a barrier. So let me go back to the basics here again. What I was trying to say is just because I'm 100% busy doesn't mean I'm getting work done. So I need to get time to solution as a baseline, but that doesn't mean it's my good point or my bad point. My baseline might be 1 hour, but once I'm tuned, my baseline might be 10 minutes. But then when I drive up the workload and get queue lengths busy, then my throughput might go down and my utilization's going up. But I'm spending more time, cache misses, TOB misses, various other processor non-productive events that are just wasteful. So health of the system, I'm a shrink, looking for behavioral problems. When I see something busy there, I take a leap of faith and assume that if the CPUs are oversubscribed, there's going to be some CPU wait time. So the health of the system, SAR, PCP, tell me what to look for. SAR, PCP are telling me how the system is behaving with the workload that's running on it. But I want to get to time domain. How long is it taking me for a man page to come up? How long is it taking me to log in? How long is it taking me for PWD to come back? How long is it taking for that car to be crashed? I need time to solution. So again, there is CSA accounting. It is retired, but it's still useful. It's just not integrated. And now I am trying to get this thing running. If you're using PBS Pro, PBS now has PBS Portal and something called PBS Analytics. And this is a brand new product from them to be able to visualize and generate reports on the PBS accounting data. So quality of the system metrics, I'm basically an accountant going in and looking at my accounting records. You know, it's like going into the family checkbook and saying, where'd all my checks go to? Hopefully they're not all to A.out or to cash or ATMs, and you can track your resources better. The third level of metric analysis is profiling. Again, I could have high CPU utilization, but I can't tell if the time to solution is productive or non-productive. So I need to profile. Profiling is where I'm looking at the service time. So for example, for us, the perf command and ps run from perf suite. Perf is from Linux and ps run from NCSA perf suite. These are the primary profiling tools that we're using. Now remember, I started using perf yesterday, and I also hung the system with that. So that's another one of my big bugs is perf top will hang your system as well. So profiling, you're not always running. You go in and tune, take a look at something, but they can impact production environment. For example, I've had cases where I've got a performance problem. I attach with strace, but strace is generating a lot of data, and it actually slowed down the application, dropped its I/O intensity, and the problem went away because strace throttled back the intensity of the I/O that it was doing. You might also be getting into profiling and looking at GDB to see if a program is stuck, what it's stuck on. So you got a program just sitting there, you're waiting it for do something, you can go in and take a look at what subroutines that program is in. And the same thing can be done with perf. I was about to do that yesterday when we panicked or hung on the perf top. But with perf, I can attach to a PID, and perf is basically periodically polling both the user and the kernel stack and looking at common subroutines, and then you can get a report. So there's perf record and then perf report to generate a report of your top subroutines. That's about where I was going to go yesterday when I hung the system. Now I spend a couple of days in this area in the UV system analysis class where we're using perf and also ps run. In fact, yesterday I was showing you data from a ps run perfx report. Perfx was the name of an IRIX tool that got to the hardware counters. So there's a ps run perfx report that allows me to look at 32, actually right now just 30 hardware counters all at the same time. And that's what I was plotting data from yesterday to be able to look at bottleneck curves and showed my 10-second program going up to 20 seconds and even at the maximum of 40 seconds for the same calculation. Sorry, but 10 seconds to 40 seconds, that's 4 times more of the work. if this is happening all the time on my system, my throughput is 75% down. I'm wasting all my time. Only 25% of that resource consumption was productive. So you need to be able to stop the non-productive resource consumption to get repeatable resource usage. And basically, again, that means CPU sets in D place. Even getting rid of interrupt handlers and stuff away from your programs. Lock it down, privatize it, make sure that no other process or thread comes into that core and uses it. Also, the perf and GDB and strace are talking about running stuff. If a process is sleeping, then I go into crash. And in particular, I'm looking for wchan, and I'm looking for a backtrace. And I spend more time in my other two classes in this area. But if somebody's trying to log in and the process is sitting there, wchan will show the subroutine that it's sleeping on, and then with crash, I can see how I got there. And I'm hoping that I can get a little bit of time and do that on, for example, an I/O application. So again, the other profiling tool is, actually I should not, this should be, I need to fix this. This is a product name, not a command. So I needed to make it uppercase in Arial, not Courier. But the two commands you run are psrun and psprocess. psrun collects the data, psprocess generates the report. And I don't know if I'll get time to demonstrate that, but again, that's part of the system analysis class. So, now that the Picasso hero is done, does anybody have any question opportunity here? So there are a variety of commands. A lot of original Linux is vmstat. A lot of people still use vmstat. It looks at CPU memory and I/O all at the same time, but it has no archive or historical capability. Top, again in top, I generally turn off priority because it is meaningless now. The completely fair scheduler uses entitlement, not priorities, to decide who runs. The only time priorities are relevant is when it's real time, and the majority of our market is not real time right now. And when you're real time, you're putting in a priority number. SAR and top kind of go together. Again, oftentimes I can't get through firewalls and stuff, and SAR is a quick way to poke through the PCP data. There's also a very useful tool, strace. I use that in I/O, for example, to track I/O request sizes. And strace does not give you system time. It gives you system calls. So some system calls result in system time, others not. The command that you really want to get system time was perf. But again, that was hanging on me when I did a perf top to get my system time. Another useful command, lsof, list your open files. If you have a large slab, a very key file in Linux is /proc/meminfo. We're going to look at that today. In fact, I started plotting it yesterday with pmchart. Slabtop is the kernel piece. When you see slab big in meminfo, then you want to run slabtop to see what it is. Traditionally, it is metadata, directory and inode information. A couple of miscellaneous things. PID stat can look at SAR data while the process is running and watch a particular process in a job mix. PS tree I use quite a bit to look at my parent process to kill the parent, not the children. Watch, I use watch quite a bit. Watch will just repetitively, I can do a watch df, watch df-h, and it just keeps it refreshed. Sock list to be able to list my network sockets. Database market, I've had cases where people were disconnecting from the database wrong and leaving a lot of dangling sockets that don't get cleaned up quick enough. And that was creating performance impact. Don't know if anybody's seen this tool. If you've used TCP dump, iptrap is a GUI. So it's basically an ASCII, I should say, it's an ASCII type tool, curses tool, to look at your network traffic in different ways. There is a GUI in Linux called XOSView. I never use it. I would much rather have pmgsys. There's a tool out there to plot SAR files called isag. There's a systat-isag package now for that. But that'll only plot one SAR file. It won't go like a week or a month. The perf utility is what's brand new with SLUS 11 SP1. That is the Linux community's profiling tool. It still has problems in it. We've got a top hang problem, but there's also internally, we've got our own version we're just calling UV-perf. And then we're trying to get those fixes back into the perf utility. Now, it requires a rebuild here, and I don't know if Dimitri does I/O or whoever is involved in I/O heavy, but in profiling I/O, I can show you how to rebuild the kernel. Actually, it's documented in the crash module, and there is an option in the config file that you flip from no to yes, and then block trace can trace each individual I/O operation. In fact, there's a utility out there to plot head movement and seek patterns and stuff like that from this. And once you've rebuilt the kernel with block trace working, then there's a block I/O monitor tool. Very, very handy. I've got a PV where it got turned off in SLUS 11 SP1. Two things that I download from the web and strongly advise you to get on your system. Nmon I started showing yesterday was extremely useful to look at disk activity. And same thing, I did not show it, but I/O top to show me when I've got I/O what the top I/O processes are. I personally can't live without those two tools. I've got to have them on my system to analyze what's going on. Any questions? So, here's the top command. We don't have a whole lot of time to cover this stuff, but the first thing is your load level. You want your load level to be less than the number of CPUs on your system. Now this load level, by the way, what is included in it is we've got, let me try typing it here, running, runnable, and sleeping on I/O wait, and also sleeping on meta wait. If I am an NFS server and I have a lot of NFS daemons running, I might have a very high load level and nothing visible here. Bottom line is what we're looking for is an IO_sched and a down type of lock. Those two things are in WCHAN. So anything that's sleeping on IO_sched is data transfers, and that's that one there. When I'm doing metadata, when I'm, for example, if I've got an email spam attack and I'm creating or destroying a lot of directories and files at one time, I'm going to have a lot of metadata changes going on in a hot log, and that's going to show up as a down lock. So all four things are part of this load level. So again, you could have an NFS server that has a huge load level, but nothing showing up in top and nothing running, because it's counting the IO waits and the metadata waits. Any questions? Anyway, the next big line is this one here. So we've got our user time. This is what we want to be productive, but I can't tell if that user time is any good without getting into the hardware counters. Then we've got our system time. Now, in this case, I can see I've got a program code 2MP running, and I know that it's got barrier synchronization problems in it, and if I were to profile that system time, I would be able to see barrier problems, things called sched yields and CPU scheduler, very busy. Most of that 12% system time in this example is the CPU scheduler thrashing on sched yields. That's something that's part of another class. After system time, we then have our nice. This is for anything that's running in a nice situation. For example, the locate utility. When find utils is loaded, there is a find that runs at 4 in the morning, and that thing runs as a nice. Then we've got idle. Then we've got our wait IO. So the wait IO here, I'm only seeing 1.6% here. But basically, I want to have WChan down here. And when I see wait O, I'm looking for a couple of different locks. IO underscore sched in the WChan field. I'm looking for block congestion, sync page, get request. How hard to read here. Get request. So these are some of the WChan events that call the IO sched lock, resulting in IO wait time. And that is data IO wait, not metadata IO wait. That's data wait only, reads and writes. There are a couple other key locks there, but those are the big ones. So then you can find out, for example, the flush daemon if it were running. Now in this top example, I've actually got a memory shortage problem because K-swap D is high. And look at my swap is all, in fact, I have no swap at all. And most of my memory's gone to 27 meg on an 8 gig system. I'm basically in what's called an out-of-memory killer situation in this machine. After the wait IO, then we have our interrupt handler time. Now it seems like in SLUS 11, things aren't showing up as much in here, and I'm seeing it show up a lot more in system time. But the hardware interrupt, the HI, the lower level, bottom level of the interrupt handler is basically clearing the interrupt bit, and then this one is handing the event off to the process that's waiting for a WChan event alarm to go off to wake up the process again. So this is kind of the software portion of handling it. This last number here, steel, is for the guest operating system. Anyway, I don't want to go much further here. Here's our physical memory. Here's how much is being used. Here's how much is free. Now, again, I don't know how many people use top, but these two I do need to talk about. Buffers is raw I/O. If I do an MD5 sum on /dev/SDA, it's going to read in that raw device. There's no file system interface. There's no directory inode or superblock. That will show up as raw I/O as buffers. Also, make swap, XFS repair, XFS ncheck, XFS db. These commands also do raw I/O. The one below it is the big one, though, cached. Unfortunately, the cached field here has a whole bunch of things in it. First of all, it's added the slab. Second of all, it's the clean portion of the cache. In other words, it's identical, it's coherent on disk as it is in memory. After the clean, we've got the dirty, which means we did a write. Once we've marked it as flushable, it goes from dirty to write back. And then from write back to NFS unstable. And then also in this metric, we also have SHMEM, shared memory, also shared text. All those things are in the cached field. And you've got to watch out for these last two. SHMEM, that IPCS command, IPCS-A could tell you if you've got unattached shared memory segments and a memory leak going on. And also, when I run out of memory, in this situation I'm down to 27 meg. When I run out of memory, we trim the cache down, except we cannot trim dirty, write back, or unstable. But one of the things that is painful to get trimmed is shared text. So there are times when you can't log into your system or you're getting very, very poor response because the scheduler, the memory manager, KSWAP-D, is not keeping your shared text in memory. Anyway, beyond that, we got PID, user ID. Again, priority is meaningless. In fact, this is an older, I've got to replace this one. This is a SLES-10 report because it's got priorities. Everything is going to be added 20 now. We now have what's called the Completely Fair Scheduler, CFS. And priorities do not shift or change. There's something called entitlement, and that kind of information is in proc sched_debug. Nices still have a meaning. Virtual is what I've reserved in malloc for my program, and then RES is what's physically in memory. Shared I don't care about. That's, you know, how much is marked as shared. S is my state, running. D for uninterruptible. S for sleeping. And D and S is a sleeping interruptible, D is a sleeping uninterruptible. D usually means I'm in some sort of I/O, uninterruptible I/O state. Then we have the %CPU. This is what I call the hog factor. So there are two modes for it. The default is IRIX mode, which basically says what percentage of my wall clock time am I actually using. I do have to be careful. I'm not sure it's the default mode. The other one is what percentage of CPUs am I using. So I'm pretty sure the hog factor is the default mode, saying during the last 2-second sample, my process code2MP was connected to the CPU 99.9% of the time and sleeping 0.1% of the time. Generally, we're trying to lock things down and make that 100%. Then we've got our percent memory use. So this code 4, for example, is using 10% of the memory I have on my system. Any questions? I'm going to move on. Okay, so here's the proc meminfo. It's really important to understand this stuff, and I'm going to plot it with PCP later. I get into this in more detail in the sysadmin or system analysis and advanced admin class. But here we have the total amount of physical memory that's available to the system. If I'm using super pages and carve out a 128 gig out of super pages, it would not be visible here. So this is memory left after PROM, after the kernel BIOS, things of that sort. Now this is a boring machine because all my memory is free. Again, this was raw I/O, and I just broke out the cached. So the cached had the clean, the dirty, the write back, the NFS unstable, shared text, shemem, and cache clean. Now there's also something called swap cache. This is where something sits both in cache and out on swap. So if I've got, for example, a shared memory text, a shared memory segment, I might run out of memory, swap the shared memory segment out, some of its pages go out on swap. The next time I need them, I bring them back in from swap, but I don't throw away what's out on swap, so that if I need to free up memory again, I don't have to swap out a second time. So there are things that can exist both in cache and in swap. And that's meant to reduce future swap outs. Then we've got active and inactive data. When I run out of memory, the first thing I'm going to do is try to trim the, the inactive file is going to go down first. Then the active file, then the inactive anon, and then the active anon. So we're kind of going to trim from the bottom up. In actuality, I should specify, we try to trim the slab first. So I got to correct myself. When I run out of memory, I'm going to try to trim the slab first, anything that's reclaimable. Then I'm going to go for the page cache. I'm going to try to trim anything that's inactive in the page cache, then what's active in the page cache. Then we're going to go to processes and try to trim anything that's inactive and then active. Now this active in and active, for people interested, there's something called swappiness. And that's a sysctl parameter that controls the balance. How aggressively do I move something from active to inactive? So a high swappiness is going to say I'm going to swap the processes, and so if I had swappiness at 100, that is going to cause the processes active to get swapped. If I set it to 0, it's going to protect the processes and cause the file active portion to get trimmed. Anyway, that's sysadmin class. We also have locked memory, the mlock system call, and then we've got information about our swap. And then I mentioned before, dirty data is data that I've written but is still in memory and has not flushed. The flush daemon will then start flushing and mark it as write back. There's dirty ratio. That's the key one. I just mentioned swappiness, but another key one here is dirty underscore ratio. And this is another important one for UV. So the dirty ratio says how quickly do we go to write back. By default, it says 40% of my memory has to be dirty before I mark it to flush. And that's a lot of dirty data. You don't want that much dirty data. Now again, once it gets marked to flush, it goes right back, and then once it's flush, it goes from right back to clean. Non-pages is my proc space, all my user space. Mapped is actually my mlock space. Mlock does not show up as mlocked, it shows up in mapped. I've got to file a bug on that one. We also track shared memory segments, and IPCS is relevant there. And unattached memory segments. Then the slab was the kernel. The rest of these I don't care about. So, now that I've put you all to sleep, was there any questions on this right now?
That dirty ratio, that's VM.dirty ratio in syscontrol?
I didn't understand the question. Dirty ratio you would put in itsysctl.conf and set it to like a 5 or a 10.
Yeah, but the tunable is actually VM.dirty ratio?
Yes, you're right. I can't hear you very well.
That's okay.
And by the way, we now support by bytes instead. So there's VM.dirty underscore bytes as well. So we can do 5% on a large machine is still a lot of dirty memory, so we can set it by bytes. We don't want the system to get too much dirty data. I want to demonstrate that today, but the system will start stuttering. Did that answer your question?
Yeah.
Now, I cover that in the Advanced Sysadmin, and we have labs in the Advanced Sysadmin on that. So I was just pointing out, when you get into memory problems, swappiness and dirty ratio are some of the key ones here. I do have an RFE open to try to get some of these set automatically by default instead of us having to tell you to do it. Any other questions? So this was just a slab top going on, and again, all I'm seeing up here is buffer header. The buffer header is my raw I/O. It's the buffer header chain. If I'm doing direct I/O, if I've got a huge cache, by the way, when I'm getting into multi-terabyte caches, the buffer header chain can get rather big too. In fact, that is another one. There is now page cache limit, and a lot of us are advising to drop page cache limit down so your page cache doesn't get too big, so this buffer header doesn't get too big and become unmanageable because it's such a long hash chain. Again, some of those tunables you have to come back to Advanced Sysadmin class for. The other thing that I'm seeing here is my metadata. So I see an inode cache and a directory entry cache. Notice this does look like it's an extended 3. I'm not seeing any XFS in this example. Now, I always do it sort by size, and that is, by size, is this column here. So I'm going to sort by what's my biggest column. So when you see slab is big, you want to be looking at this. Here's just a quick SAR-DP for my disk drives. Again, remember partitioning corrupts the SAR file for that day. So of interest to me are these far right. Again, I said I want this one to be less than 30%. And these two I want to be less than 60 milliseconds. So if my drive is busy, high utilization, my service and waits look okay, I look for head movement, fragmentation, journal activity, lots of little IOPS. Lots of head movement. Anyway, again, I am using NMON rather than this on UV right now. So we're finally to Performance Co-Pilot. So PCP is now based upon the open source version. SGI is no longer the upstream maintainer. The engineers that worked on PCP and started it are the upstream maintainers as an open source project. And with this, half of it used to be open source, but now the GUIs and the rest of it are open source. And the one last piece was the 3D view called PMView. That got released to the open source group this last summer. And that'll give me MPViz and OSViz and PMHub and stuff like that. See, I was off there yesterday, oss.sgi.com projects PCP, and I'd gone off to a download to be able to actually download and showed you there's Debian and other versions there. So there is a new pmchart and a new PCP-GUI. The PCP SGI is for SGI Altec specifics. So there is a old pmchart. In actuality, I don't think this was my slide, but I don't think the UV PDMA is in there. That's part of pmcd. At the time, it was a PMDA, but now it's been moved as a DSO. There's no actual separate process for UV statistics. Now, Dimitri had asked about this, and I need to get to that in demo here. Anyway, pmchart and pmgadgets are now open source. PMView is what I said is not implemented yet. Was given to the PCP community, but I don't think it's in the tree yet. They're in the process of getting that. So PCP is now available for SLES, but you have to build from source or grab an SGI RPM. The open source stuff is on the foundation, SFS. And I did notice, for example, it was on ISSP. It looked like it was actually on a couple of the distributions, not just the foundation. I need to check into that as we get closer to MR to see if they've moved them again. The RPMs that are on the website are for Red Hat. There's also a Debian tree, a Solaris, Windows, and a Mac OS. And a new nice feature now, the PMDAs can be in Perl now. You don't have to write C. So this is just trying to show a client-server distributed architecture concept. So I've got some sort of remote host I'm going to monitor. I have a pmcd running there, and then I can sit here with a pmchart and talk to it. And then anything else that I want to collect, I create a PMDA. Performance Metric Domain Agent allows me to add metrics to the metric pool. For example, we can add XVM statistics. In the future, we'll probably be adding temperature, voltage, fan speed information. In a tempo cluster, there are PMDAs for the nodes themselves for a lightweight cluster architecture. So these are the commands for PCP, the key ones to play with in lab. We want pmcd running. So once you install PCP, check config it on. That thing should be up and running all the time. There's going to be a step in the lab to set up pmlogger to create archives, pmid for an alarm, pminfo to find out what metrics are available. pmval will get a value for a metric. Read it. We can add XVM statistics, and this is what Dimitri was talking about. I don't know if he ever finished it, but there should be a dash capital A on linkstat-uv to activate the hub statistics. So when you do that, I want to do this here, you'll get a UV PCP group. I want to get to the demo on that. For looking at the system, the main one was pmchart. There's a little widget called pmgsys that allows me to look at a single system, or we saw pmcluster where we could put all four. We had to do that, by the way. We created a /etc/nodes file and put all our nodes within that file, and then pmcluster could show all the nodes. These OSViz ones, these are a 3D using PMView. They're coming out of the PCP SGI package right now, and in actuality, there are scripts that call PMView. PMView is the actual graphic interface. Some of these things like pmgsys, pmgcluster, OSViz are scripts. And again, just to review, pmgcluster is calling pmggadgets. For a multi-CPU system, mpviz, I missed one, dkviz for disk. Also part of PCP is node info. Now that's part of PCP SGI. And then we've got NFSViz, ClusterViz, there's an XVM, and if you're on Tempo, PMICE. So these PMDAs, Performance Metric Domain Agent, is a way of adding metrics. So the ones that we would use in the Advanced Sysadmin class would be like the XVM one. What's another common one here? There's a DMF one that got added. I'm just seeing if there's any others of interest here. Luster. Some people are running Luster. There is an Apache one as well. There is an Oracle one, but it's not integrated and tested. But if anybody does want a PCP Oracle interface, I've got the background on that and the code for it. It is in the PCP tree, Dimitri. It's just not integrated yet and tested. I know Dimitri's on the list for PCP. So here's my main interaction. Everything's coming out of /proc or /sys. I should have /sys in there as well. So pmcd is reading that stuff. This PMDA UV, that's old. It got taken out. pmcd is calling it directly now. So pmcd actually has a DSO. There's a library. The problem was the timeout. If pmcd didn't hear from a PMDA, it would time out. So under heavy loads, the PMDA UV would drop away. So now that is really a DSO being called from PMCD. You should see it as a separate thread being spawned off from PMCD, but it's not an actual separate PMDA process. Question? I was just hearing some clicks. We'll go a little bit further and then take a break here. Question?
No.
Okay. I don't play with it in here, but we can try that in demo to bring up a PMDA for the XVM statistics. I can read raw data from it with pmval. Oops, this is old. And we don't even have a PM hub right now. It's not completely implemented, but it will drop the S. There's a PM hub in the works, but that's not there right now. pmchart is the main bread and butter. PMIE is my alarm mechanism. Now, when it sets off an alarm, it writes into varlog messages. The rules for the alarm are in this file here, and there will be a lab in there to be able to turn on these rules and change a rule. And PMIE conf is how I configure these rules. ESP, by the way, does have an interface to turn these alarms on and off, but it's broken. I've got a bug on that one. Also, keep this in mind, ESP is supposed to be watching PMCD to make sure it's running. If PMCD gets killed or something, then ESP, if it's not running, PMCD would never get restarted. By the way, one of the things that I'm doing is if I echo a -17 into /proc / whatever the pmcd.pid is, _adjust. That would prevent the out-of-memory killer from killing pmcd. Again, cover that more in the advanced sysadmin class. The other part then was the logger activity. So all the logs, all the archives are going to the varlog PCP pmlogger host name and then date. And there is a daemon up and running, pmlogger daily, from a cron event that cleans up that directory. If I have multiple for a day, it will merge them into one per day. Also, I have a cron event that has to be put in place to make sure pmlogger does not crash. We do not want to get to the end of the month and not have data to give to our data center manager. And there is a config.default varlib PCP config pmlogger that says what metrics you want to save in there. And I've got my own version of a config.default that you'll play with in lab. Any questions? So I need that PCP on, PMIE on. I'm going to set up a config.default. I also have to edit this control file. So I have to configure whether I want an archive or not by saying I'll go into there and configure that. Then I'm going to set up PMIE with PMIE conf. I've got to drop a cron event in place, and then I'm going to restart my services. No reboot required. So once it's up and running, pminfo will get me my metrics. I'm a person that looks at this data all the time. First thing I do with the system is get my pminfo. I actually use the little t first because it's shorter and quicker. Again, once I add additional probes, like PMDA, additional metrics will be available. I'm going to have to turn on the UV statistics to get them available. And we do have probes for Brocade switches, Cisco routers, Shiping, Oracle, Apache, stuff like that. So here's an example of the varlib PCP config pmlogger config.default. I'm going to say every 5 minutes, give me a sample. Again, I'm looking at CPU here, memory here, disk here. And there is an access control as capability to it as well. Now, I myself just edit this raw file. There is a pmlogconf command to go into it as well. But I usually just drop an ASCII file into place. So I'm going to get into demo here. We started off, I'm going to take a break. We'll come back and do demo. But I started off yesterday and brought up pmchart. I went to File and said Open View, and then I got predefined views. So in varlib PCP config pmchart, I chose the CPU one, and there were some other ones in there as well. By the way, there are some views that are not views. I've got to file a PV on that. So this is the part that I wanted you to be comfortable with before you come into the later classes, and that's to be able to build a memory chart. So this is where I left off yesterday. Here was my CPU chart. Here was swap. And then I left off building memory. So the lab is going to walk you through this, but again, I'm trying to get a, for those that do gross view and IRIX, get a gross view type to display. So I want to build a stack plot, and I actually had to do it twice yesterday. So I want to get slab first, the kernel, then the raw IO, then the dirty, the write back, the NFS unstable, then the clean, then the map, then a non, and what's missing here then is free. And the lab manual has a screenshot of this, of what I want it to look like before you hit the apply. And don't forget about this one. If you want to get rid of a metric there, there's the stop sign. If you want to find out about a metric, you can actually click here and get info, the pminfo type of data. I'm going to have to come back to that to demos and labs. So here was an example that I was going to try to do here after we take a break. So I've got basically memory down here and swap here. So this is basically virtual memory. Different machine though. So down here, the blue, I had some raw I/O going on down here. So some raw I/O going down here. The red was dirty, so there's some dirty data sitting here. Right on top of that, there's my write back. This is stuff that's flushing. and then no unstable, but then this is my cache clean. Also had mapped going on here, and that was this, looks like the blue here. And at that point right here, we actually ran out of memory and started filling up swap. Look at the stalls. These right here are places where we actually dropped data. And then right here, that's my That's my out-of-memory killer. Things had to start dying during this interval. In fact, something finished up right here, and all the swap, and what was it here? This green was the cache clean. More than likely for me, I'm suspecting this was Shemem. Yellow was my application and non-pages. It looks like I then started something else that started coming in here. And I topped off, let's see, yellow was a non. So right here, all my memory is basically a non-pages. There's a command I use called memhog to actually create memory load conditions. Now, I would spend a lot more time in this kind of thing in the system analysis class and create different types of performance events. But this one's basically an killer event. Any, have I totally lost you? Are we okay? If you notice down in the lower left, this is just live. I can go under record and start recording. And then later, it will come up with a record button, and then later I can take that archive and play it back. I need to do a -A on the file. And again, if you don't have PCP on your workstation, you're going to have to use VNC Viewer Remote Desktop to be able to look at some data. So when I'm in archive mode, I've got a VCR type paradigm. I can take the slider and slide it back and forth. I can play forward, play backward, and control the speed with which I'm going through the data. How quickly am I playing it back? So PCP has per hub statistics. This is all obsolete. Don't need to do that anymore. We also have node info, getting data from here. There's the topology command. Topology is just kind of showing the router interconnection. So this is what was missing, Dimitri. This is what we needed to do to get those UV statistics and the hub stats that you're talking about. So there's a link stat-uv command now, and here it's giving me my ports and then what my bandwidth is and what my utilization on the port is. And then some of the peak stuff over here, errors, things of that sort. So what I've done here now, I brought up pmchart. Again, I had to have the statistics turned on, and then I got a UV group. And there's a lot of stuff in the UV group, particularly when you're talking about lots of ports. That's the hard part. How do I visualize this sort of data? But I expanded the Numalink, and then I went into traffic, and then I did receive bytes in this particular chart. Looks like I did both receive and send. So here I can see an application running, and then when the application finished, the burst of Numalink traffic as it finished up. So I want to try to demonstrate that. This is rather nice. I don't know if, Dimitri, you've used this yet, but I now have the ability to put in my home directory a file called derived, and then I can create my own metrics. So I was creating two of my own metrics here and computing them this way. Something that I like a lot, be able to compute my own metrics. Here's pmgsys. We saw this yesterday. I'm going to bring one up for our cluster. And then we got mpviz, dkviz, osviz. Osviz is more network-oriented. Here's node info. So here I can see on a per node basis how much is dirty, apps, or kernel space. And I also, in this case, am able to see everything is hitting. This is what you want to see. I don't want to see misses or foreigns. Top disk is broken. Can't use it. You're going to find all the stuff over on the right is corrupt. Again, I'm using nmon right now. Top sys gives me the processor giving me my top system time, but again, I would also be looking at perf top once perf top is fixed. Again, perf top will hang your system.
Did they ever get buff view ported?
Did you say buff view?
Yeah.
No. You're into my fantasy land now. BuffView is an extremely useful tool on iRigs. I would love to have it on Linux, but no. BuffView basically looked at the assets in your cache and would tell you what files were in the cache, how big they were, how many buffers they were using, how old they were. It was like a top for the buffer cache, which Linux people call page cache. I'd give anything for BuffView. Anything else? So again, TopSys will give me the top processes. Now this is part of another class, but Code 5 has to be metadata intensive. It's creating a lot of directories and inodes. But I wouldn't be able to tell that until I profiled. PMIE, as I mentioned, it's an alarm mechanism. By default, it's going to write into varlog messages. We can also get ASCII to the console or pop up a graphic or run a shell script. The default is to write messages. The roles are located in this directory, but the templates are in a PMIE conf directory. So here I went into PMIE conf, did a help, so I can list my rules, I can enable or disable a rule, I can list a particular rule, modify the rule, and get verbosity. So here, again, some of these rules are coming from PCP SGI right now. The rules have changed quite a bit. I'm still missing a bunch of rules. So here I did PMIE conf and then typed in rules. This one is of interest to me, this one is of interest to me, this one's of interest to me. I'm not seeing one here for running out of memory, for example, which I probably would want. And then here's an exact rule. So here we're listing a rule saying on a per CPU basis, if I get some utilization, and the threshold is 95%. So if 95% of a CPU is busy, then we're going to write a message into varlog messages. Looks like it wrapped here, but this is another one here. This is a file system filling rule. So they're computing used over capacity times 100, so they're saying percentage. If we're greater than 95%, and if what we've got used plus a 20-minute window rate, saying if the rate of file growth is occurring at this rate for the next 20 minutes, are we going to exceed a 95% file system full condition? If so, then we're going to write into syslog. So here's the action down here. And then I'm going to write into syslog once every 10 minutes. This is for ESP to see. And then we're going to say file system is filling, and it'll give you it's wrapped here, but it will give you the name of the file system, or I should say the major, minor number type of information, or path type of information for the file system that's filling. And that's it. I'm ready for a break. Any questions on the slides right now? Let's come back at 5 minutes to the hour.